everyone, and welcome. Today, we're going to dive into a really cool and fundamental feature in Java that helps make our code so much cleaner and more intuitive. It's this whole idea that a single name can actually do multiple totally different jobs. We're about to see exactly how that works.
All right, so let's kick things off with the central question here. Just imagine you're building a calculator app. You obviously want it to add numbers, but think about it. Sometimes you're adding whole numbers, like 5 and 10. Other times you're dealing with decimals, like 2.5 and 3.7. How can we possibly use this same simple add command for both of those without completely confusing the computer? Well, that's exactly the problem we're going to solve.
The secret sauce behind all of this is a really powerful principle called polymorphism. I know, it's a big word, but it comes from Greek and it literally just means many forms. In the world of programming, it's basically the magic that lets a single name or action behave differently depending on the situation. It's the foundational idea that makes our add command so flexible.
Okay, but here's the thing. Polymorphism isn't just one single idea. It actually comes in two main flavors. First, you've got compile-time polymorphism, which is also called static. This is where all the decisions are made and locked in when you're building the code. Then there's runtime polymorphism, or dynamic, where decisions are made on the fly while the program is actually running. For this explainer, we're going to zero in on that first type, the compile-time solution.
And that brings us to the star of our show today. The specific technique we use in Java to achieve this compile-time magic is called method overloading. This is the tool that's going to let us solve our calculator problem.
So what is it exactly? Well, method overloading is actually super simple. It just means you can have a bunch of methods in the same class that share the exact same name, with one crucial rule. Their parameters have to be different. That's it. You can either have a different number of parameters, or the types of those parameters can be different. As long as you follow that rule, you're good to go. Theory is one thing, but seeing it in action, that's where it really clicks. So the best way to get this is to just build something. Let's put together a really simple calculator class and see how method overloading works in the real world.
All right, first things first, we lay down the blueprint. We just declare a class called calculator. Think of this as the main container that's going to hold all of our different adding functions. Pretty straightforward, right? Now, inside our calculator, we're going to define our very first add method. Take a look at its signature. It's named add, of course, and it's specifically built to take two integer parameters, a and b. Its only job is to add those two together and then print out a message telling us it's the sum of integers.
And now for part two. We define another add method. Yep, it has the exact same name, but, and this is the key, look closely at the parameters. This version is designed to accept two double values, numbers with decimal points. It does the same addition, but this time it prints a different message saying it's the sum of doubles. Okay, our calculator is officially built. Time to fire it up and see what it can do. So, in our main program, we create a new calculator object. Then, we call the add method twice. The first time, we give it two integers, 5 and 10. The second time, we give it two doubles, 2.5 and 3.7. See? Same method name, totally different types of data. And voila! Here's what we get when we run the program. It works perfectly. The call with the integers, calc.add 5, 10, gives us sum of integers 15. And the call with the doubles, calc.add 2.5, 3.7, gives us sum of doubles 6.2. The program knew exactly which version of the add method to use for each situation. No confusion at all. So how in the world did that happen? It kind of feels like magic, right? But it's not. It's actually a very clever and logical process. The secret isn't in the program while it's running. It's all handled by the compiler before the program even starts. Let's put ourselves in the compiler's shoes for a second. Here's what it does. First, it sees a line of code calling a method, like calc.add510. Second, it looks at the arguments you provided. In this case, it sees two integers. And finally, it scans through the calculator class looking for an add method whose parameters perfectly match those two integers. And it finds one. It does the exact same thing for the doubles. It's really just a simple matching game. And this is the most important takeaway here. This whole decision, this process of linking the method call to the specific piece of code, it all happens during compilation. That means it happens before your program is ever even run. That's precisely why we call it static or compile time polymorphism. The path is already paved and set in stone. All right, let's take a second to pull everything together and just quickly recap what we've learned about this really elegant feature in Java.
So, when you boil it all down, what's the deal with method overloading? You can use this same method name over and over, as long as the parameters are different, either in how many there are or what type they are. And the real secret is that the Java compiler figures out which one to use before the program runs. It's all about making our lives as programmers easier, right? Instead of having to remember add integers and add doubles, we just have to remember add. It's clean and it's intuitive. Okay, so we've established that the compiler is super smart, and it makes all these decisions before the program even launches. But that leads to a really interesting question. What if a decision can't be made ahead of time? What happens when the choice of which method to run depends on something that happens while the program is running? Well, my friends, that opens up a whole new world. And that's a topic for another day, called method overriding.